Hi students, welcome to TSAT channel. Here let us continue about our physics episodes. A previous here we are discussed up to gravitation, where continuation. See children, I see on the screen. What will be the formula of mass of the earth in terms of G, R and G? Okay children, here G is a universal gravitational constant and capital R is a radius and small g is a acceleration due to gravity. Okay, you know that the relation between small g and capital G, G is equal to Gm by R square, Gm by R square. Therefore, here we want to find out the mass value. What is that? Mass m is equal to Gr square by capital G. Okay. See in our option, first option Gr by G, second option Gr square by G, and third option G square R by G. Here therefore here m value actually that is Gr square by G, small g R square by G. Here the option 2 is there children, check your answer here, option 2 Gr square by G. Okay. And next question, for a given material the Young's modulus 2.4 times that of rigidity modulus, then its Poisson ratio. What is a Poisson ratio? Here the formula, the relation between Young's modulus and Poisson ratio and here rigidity modulus, that is y is equal to 2 neta into 1 plus mu, 1 plus mu. This is a relation children, keep in your mind. Y is the Young's modulus, here this is the neta, that is called as the rigidity modulus, and mu is the Poisson ratio. Okay, here the which value find out that? It's a Poisson ratio value, find out that. Okay, Young's modulus value is given 2.4. 2.4 is equal to 2 into here, what is that here? Young's modulus is 2.4 times of the rigidity modulus. Okay children, therefore here this is 2.4 into what is that? Neta. Neta into 2.4 is equal to 2 into neta 1 plus mu. Okay, see children, this nu get cancelled, that is 2.4 is equal to 2 into here 1 plus mu. Okay, therefore 1 plus mu is equal to 2.4 by 2, 2.4 by 2, that is what here? What is the value? 1.2. 1 plus mu is equal to 1.2, therefore mu is equal to 1.2 minus 1. This is equals to the 0.1. Okay, here mu is equal to 0.1. That is Young's modulus value is n times, that is y place we are substituted, neta into 2.4 is equal to 2 neta into 1 plus mu. Neta cancel అయిపోయిందమ్మా, ఏం మిగిలింది? 2.4 is equal to 2 into 1 plus mu. Therefore 1 plus mu is equal to ఏమవుతుంది 2.4/2 అవుతుంది, that is 1.2. Therefore 1 plus mu is equal to 1.2, therefore mu is equal to 1.2 minus 1, that is 0.2. This value is 0.2. Yes or no? 1.2 minus 1, 0.2. That is the fourth option. Check your answer. That is fourth option. Next here, according to Hooke's law of elasticity, the ratio of stress to strain. Okay children, you know that what is the Hooke's law? Hooke's law say that the stress is directly proportional to the strain. Here stress by strain, that is equals to the constant. Okay children, therefore here the option is given Hooke's law. And here one more important point, within the elastic limit, that is a condition children. What is the Hooke's law? Within the elastic limit, the stress is directly proportional to the strain, and stress by strain is equals to the constant. Therefore see children, the option 1 is the correct answer. Option 1, see option 1 here, remain constant is the correct answer. Okay, and next here, see a spring of force constant 800 Newton per meter as an extension of 5 centimeter. Okay, the work done in extending it from 5 centimeter to 15 centimeter. Okay, and here work done. What is the work done here in this? Work done is equals to the formula UI minus UF. You know that in the here conservation of work energy theorem, the changes of the kinetic energy is directly proportional to the work done. But here also this here the formula work done is equals to the here UI minus UF, and here work done is equals to the work done is equals to the 1/2 of K x1 square minus x2 square. This formula is also applicable, and you know that 1/2. The question is given, K is what here? Spring force constant. Okay children, that is 800. Okay, and as an extension 5 centimeter. The work done is extending it from 5 centimeter to 15 centimeter. Here you convert in SI system. What is that SI system? 5 centimeter is equal to how many meter? 5 into 10 to the power minus 2 meter, and 1 centimeter is equal to 10 to the power minus 2 meter, and 15 centimeter. What is that? 15 into 10 to the power minus 2 meter. Okay, therefore here x1 square, you substitute 5 into 10 to the power minus 2 whole square, minus x2 how much? Here x2 value here you take that is the difference you can take, that is 15 minus 5, that is a 10 you can take. Here 10 into 10 to the power minus 2 whole square. Okay. Then you simplify them, this is equals to the here 400, you calculate them, this value is minus 8 joule. But here work done of spring is minus 8 joule. But therefore, what is the kinetic energy total value? You know that work external plus and WDS work done is equals to the what? Changes of the kinetic energy. Therefore, here delta K is equal to 0. Therefore, what happened? We want external work done. That is equals to the minus WDS. Here minus WDS value already you know that minus 8. Minus into minus plus 8. Therefore, here 36 quotient. Here second option 8 joule is the correct answer. Therefore, work done formula 1 by 2 K into x1 square minus x2 square you apply. And next here this question you see that children, the surface tension of water is 7.3 into 10 to the power minus 2 Newton for meter square. The excess pressure inside the spherical drop of water annappudu pressure P is equal to 2T by R formula తీసుకోవాలమ్మా. సోప్ బబుల్ అన్నప్పుడు P is equal to 4T by R అని తీసుకోవాలి. ఎందుకంటే ఆ లేయర్ 2 సైడ్ ఉంటుంది కాబట్టి ఇక్కడ ఏమన్నాడు, వాటర్ ఆఫ్ రేడియస్ 1 millimeter ఈజ్. ఓకే. therefore you find out that what is the formula here, pressure P is equal to 2T by R formula 2 into here T is what here, surface tension. What is that? 7.3 into 10 to the power minus 2 by here radius. See children, 1 millimeter is given. 1 millimeter. Here what is 1 milli? 1 millimeter is equal to how many meters? Milli. That is 10 to the power minus 3. Okay children. Therefore here how much here? 2 into 7.3 14.6 into 10 to the power minus 2. 10 to the power minus 3 you take that up 3 minus 2. Therefore 14.6 into 10 to the power 3 minus 2 1. That is here 146 into 10 to the power minus 1 plus 1, that is cancel. Here minus 1 plus 1, that get cancel. 146 is the answer. Okay children, 146 is the answer. Pressure 146, pressure unit is what here? Pascal. Therefore 146 Pascal is the answer. Okay. If suppose same type of the problem, if suppose given on the question, so bubble is given, then you take that 4T. Okay, keep in your mind. And here Next, if temperature of a liquid is increased, then its surface tension is decreases. Temperature increase అయినప్పుడు లిక్విడ్ యొక్క హియర్ టెంపరేచర్ ఎప్పుడైతే ఇంక్రీజ్ అవుతుందో సర్ఫేస్ టెన్షన్ అనేటటువంటిది డిక్రీజ్ అవుతుంది. ఎందుకంటే మాలిక్యూల్స్ మూవ్ అవుతూ ఉండేటటువంటి సందర్భాలు, బికాజ్ కైనెటిక్ ఎనర్జీ ఆఫ్ ది మాలిక్యూల్స్, ఎఫెక్ట్నెస్ ఆఫ్ ఇంటర్ మాలిక్యులర్స్ అట్రాక్షన్ డిక్రీజెస్. ఎప్పుడైతే హీట్ చేస్తామో హియర్ హీట్ చేసినప్పుడు ఏమవుతుందమ్మా, మాలిక్యుల మధ్య అట్రాక్షన్ అనేటటువంటి తగ్గిపోతుందంట. ఓకే, కాబట్టి అందు గురించే సర్ఫేస్ టెన్షన్ తగ్గిపోతుంది. ద సర్ఫేస్ టెన్షన్ వాల్యూస్ డిక్రీజెస్ ఇన్ ద లిక్విడ్. ఆల్రెడీ యూ నో దట్ ద సర్ఫేస్ టెన్షన్ S is equal to F/L. The unit length acting force is known as surface tension. S is equal to F/L. Okay, Newton per meter. Dimensional formula ఏంటిదమ్మా? డైమెన్షనల్ ఫార్ములా ml T⁻⁻² by L. LL get cancel, m T⁻⁻². You can also write that m⁻⁻1 L⁻⁻0 T⁻⁻². This is the dimension formula of the surface tension. And here surface tension యొక్క డైమెన్షనల్ ఫార్ములా స్ప్రింగ్ కాన్స్టెంట్, ఫోర్స్ కాన్స్టెంట్ దానికి కూడా సమానంగా ఉంటుంది, గుర్తుంచుకోండి. ఆస్క్ ఇన్ ద ఎగ్జామినేషన్ హియర్ surface tension dimension formula is equals to the one physical quantity dimensional formula. అండర్ 4 ఆప్షన్స్ ఇచ్చాడనుకో, దాంట్లో ఫోర్స్ కాన్స్టెంట్ కానీ స్ప్రింగ్ కాన్స్టెంట్ కానీ ఉంటే కూడా కరెక్ట్ అవుతుంది, గుర్తుంచుకోవాలి. బట్ హియర్ ఇన్ దిస్ క్వశ్చన్ when temperature is increases the surface tension value decreased. Okay children, the wettability of surface by a liquid depends primarily on here. ఇక్కడ ఒక విషయం చెప్పాలమ్మా మీకు జాగ్రత్తగా. ఏంటిదంటే మనం చూస్తూ ఉంటాం హియర్ చెట్లు ఎప్పటికీ కూడా పచ్చగా ఉండడానికి గల కారణం ఏంటంటే అసెండింగ్ క్యాపిలారిటీ అంటామమ్మా. ఈ విషయం తెలవాలి మీకు. ఏంటంటే సపోజ్ ఒక బౌల్లో ఒక కంటైనర్లో ఒక క్యాపిలర్ ట్యూబ్ని ఉంచామనుకోండి, క్యాపిలర్ ట్యూబ్. ఏమవుతుంది, సపోజ్ వీఆర్ టేకింగ్ ద వాటర్ దట్ రైజెస్ ఇన్ అప్. హియర్ this angle is called as the angle of contact. The angle between the solids and liquid is known as angle of contact, which substances the angle of contact value is less than 90 degrees, that liquid is rises in upward side. Okay, కాబట్టి చెట్టు చిటారు కొమ్మలకు కూడా నీళ్లు అందడం జరుగుతుంది because of ascending capillarity. Theta is less than 90 degrees. Angle of contact value is water less than 90 degrees అంటే theta 0 అమ్మ, గుర్తుంచుకోవాలి. Angle of contact value of water is 0 degrees. Okay, if suppose అంటే kerosene stove, okay, that is also angle of contact value is less than 90 degrees. అదేవిధంగా క్రొవ్వొత్తి క్యాండిల్ దానికి కూడా లెస్ దెన్ 90 degrees ఉంటుందమ్మా, గుర్తుంచుకోవాలి. సపోజ్ యు ఆర్ టేకింగ్ ద మెర్క్యూరీ తీసుకున్నారనుకోండి అమ్మా. ఇక్కడ మెర్క్యూరీ తీసుకుంటే సపోజ్ వాటర్ ఇక్కడ మెర్క్యూరీ లెవెల్ ఇక్కడ ఉంటే ఈ ట్యూబ్లో క్యాపిలరీ ట్యూబ్లో ఇలా కిందికి వెళ్తుంటుందమ్మ. ద యాంగిల్ ఆఫ్ కాంటాక్ట్ ఆఫ్ ది మెర్క్యూరీ ఈజ్ హియర్ 140 degrees. దట్ వాల్యూ ఇస్ theta is greater than 90 degrees. ఓకే, కాబట్టి గుర్తుంచుకోవాలి. therefore here the wettability of the surface by a liquid depends primarily on the angle of contact between the surface and the liquid. గుర్తుంచుకోవాలి మీరు. ఓకేనా? హియర్ ఇక్కడ 4 వర్డ్స్ కూడా ఇచ్చాడు అక్కడ. డెన్సిటీ, వాట్ ఈస్ ద మీనింగ్ అబౌట్ ద డెన్సిటీ? మాస్ బై వాల్యూమ్. విస్కసిటీ, Suppose fluid is flowing from one place to the another place. That is nothing but a number of layer. Upper layer force acting in downward side layer. పైన ఉండే లేయర్ కింద ఉండేటటువంటి లేయర్ యొక్క వెలాసిటీ డిక్రీజ్ చేయడానికి ట్రై చేస్తుందమ్మా. హియర్ బాటమ్ సైడ్ లేయర్ ట్రై టు ఇంక్రీజింగ్ ద అప్పర్ సైడ్ లేయర్ velocity. This type of force is known as viscosity forces. ఆల్రెడీ సర్ఫేస్ టెన్షన్ గురించి మీకు చెప్పాను. ఏంది సర్ఫేస్ టెన్షన్ force by length. Unit length acting force is known as surface tension. Okay, and here the temperature at which the reading of a Fahrenheit thermometer will be double here that of centigrade thermometer. Dear students, ఇది చాలా ఇంపార్టెంట్. మీకు ఎప్పుడైనా టెంపరేచర్ ఫైండ్ అవుట్ చేసేటటువంటిది ద సెల్సియస్ స్కేల్లో, ఫారెన్హీట్ స్కేల్లో, అదేవిధంగా కెల్విన్ స్కేల్లో ఫైండ్ అవుట్ చేస్తాం. ఈ ఫార్ములా మీకు తెలవాలి. C/100 ఈజ్ ఈక్వల్ టు F minus 32 by 180 is equal to K minus 273 by 100. ఈ ఫార్ములాను బేస్ చేసుకొని మీరు ఏదైనా కన్వర్ట్ చేయొచ్చమ్మా. ఇక్కడ ఏమన్నాడంటే హియర్ ఫారెన్హీట్ థర్మామీటర్ విల్ బి డబుల్ ఆఫ్ దిస్ సెంటిగ్రేడ్ అన్నాడు. కాబట్టి F ఈజ్ ఈక్వల్ టు 2C సబ్స్టిట్యూట్ చేయండి అమ్మా. F ఈజ్ ఈక్వల్ టు 2C సబ్స్టిట్యూట్ చేస్తే ఏమవుతుంది? హియర్ యూ టేక్ దట్ దిస్ రిలేషన్. ఓకే, హియర్ C by 100 is equal to 2C minus 32 by 180. ఓకే చిల్డ్రన్స్, నేను ఏం చేశాను? ఎఫ్ ఉన్న ప్లేస్లో 2C సబ్స్టిట్యూట్ చేశాను. ఇట్లాగే ఈ 0 క్యాన్సిల్ అయిపోతుంది. అండ్ హియర్ సీ దట్ C క్రాస్ మల్టిప్లికేషన్ చేయండి, ఏమవుతుంది ఇక్కడ? హియర్ 18C. ఓకే, హియర్ 18 is there na. 18C is equal to 10 into 2C minus 32. క్యాలిక్యులేషన్ చేయండి అమ్మా. 18C is equal to 20C. Here 10 into 32 minus 320. Okay, therefore here in this equation 18C minus 20C minus into minus plus 320 is equal to 0. 18 minus 20 minus 2. Okay, minus 2C is equal to minus 320. Okay, here minus get cancel, therefore C is equal to 320 by 2. Okay, how much? 160. Therefore C is equal to 160 Celsius. ఓకే చిల్డ్రన్, డబుల్ అయిపోతుంది అది ఫారెన్హీట్లో. చూడండి 320 అవుతుంది. కాబట్టి విచ్ క్వశ్చన్? ద ఫస్ట్ ఆప్షన్ ఈజ్ కరెక్ట్. కాబట్టి డియర్ స్టూడెంట్స్, C/100 ఈజ్ ఈక్వల్ టు F minus 32 by 180 ఈజ్ ఈక్వల్ టు K minus 273 by 100. ఈ ఫార్ములాను యూజ్ చేసి మీరు ఏ విధంగానైనా కన్వర్ట్ చేసుకోవచ్చు. ఓకే, నెక్స్ట్ హియర్ యు సీ the pressure of a given mass of gas is 100 centimeter at 127 degrees centigrade. The pressure of the same mass of gas having the same volume at 27 degrees centigrade. Here you know that the formula, what is that? Gases laws. What is the gas laws, children? Charles laws. What is the Charles laws? P proportional to T, okay, or P is equal to KT, or P1 by T1 is equal to P2 by T2, so on. ఇది మనము చార్లెస్ కాన్స్టెంట్ వాల్యూమ్ లా అని రాస్తామమ్మా. దీంట్లో నుంచి మీరు ఏం చేయాలి అంటే P2 వాల్యూను కనుక్కోవాలి. P2 వాల్యూను కనుక్కోవాలి. therefore P2 is equal to ఏమవుతుంది? here P2 ఇది ఇక్కడే ఉంచండి, దాన్ని అటు పట్టుకపోండి. ఏమవుతుంది? T2 by T1 into P1. ఓకే, here T2 ఇందులో టెంపరేచర్ విషయం చూడండి. ఒకటి here what is the value is there? 127 degrees. Here you convert the Kelvin. 127 plus 273. How much? 400. Okay. Another one is 400. Okay. See, next one is 27 plus 273. Okay, 273. One is 300. Okay, children. Therefore, you substitute the value. You substitute value 100 into 300 by 400. Okay, therefore 0 0 cancel, and 100 into 300 by what is that? 4. 300 by 4, this is equals to the, what is the value? 75. 75, students. Therefore here the pressure 75. See that answer. This is, if suppose two different pressure values are given, temperature values are given, you find out the another pressure value. And here a block body has maximum wavelength lambda m at 2000 Kelvin. Its corresponding wavelength at 3000 Kelvin will be. Here you apply Wien's displacement law, children. Here Wien's displacement law. What is the change? That here maximum wavelength is inversely proportional to the temperature. According to this one, lambda m1 T1 is equal to lambda m2 T2. This formula, children, you find out the lambda m2. Okay, we want find out the lambda m2 value. That is what here? Lambda m1 T1 by T2. This formula you apply, you substitute the value. Here what is that? Lambda m1 is equal to, suppose you take that lambda m, and T1 temperature is given how much here? 2000 Kelvin is given, and here next to T2 is 3000 Kelvin. Okay, 3 digits cancel. That is what is that? 2 by 3 lambda m. 2 by 3 lambda m. That's option is second option, children. Second option. Keep in your mind. Here Wien's displacement law, maximum wavelength is inversely proportional to the absolute temperature. Absolute temperature, you know that, children? Absolute temperature, Kelvin temperature, or thermodynamic temperature, these all are same. At which temperature the pressure and value is equals to the 0. the temperature is known as absolute temperature. Okay, and keep in your mind this formula is the most important. Okay, and here next one, there are two lead spheres. There are two lead spheres at the same temperature. The ratio of radius being 1:2, the ratio of heat capacities are generally volume of here the volume of the first sphere 4/3 pi r square, first sphere, here first sphere what here 4/3 pi r cube, children, and here volume of the second sphere, that is 4/3. What happened here? Pi, the radius is double, that is 2r cube. Okay, 2r cube means what here? 4/3 pi 8r cube, children. Okay, the ratio, what happened this ratio? Here the ratio of first sphere and second sphere is that ratio. Ratio is equal to 4/3 pi r cube, 4/3 pi r cube get cancelled. Here what is available? 1/8 is available. Okay, see that here. Here first sphere 4/3 pi r cube is a common. Second sphere also 4/3 pi r cube is a common. Therefore what happened here? 1/8. Okay, therefore here ratio of the volumes, this is a ratio of the volumes, ratio of the volumes. Okay children, ratio of the volumes. And here you know that capacity of the any object, heat capacity, here this is the important point children, heat capacity is a directly proportional to the here what its volume. Heat capacity is directly proportional to the volume. Therefore children, heat capacity ratio is also 1:8. 1:8. Okay. Yes. Dear students, here what we are going to be discussing in the first year chapters. Here these all problems came in previous EAPCET examination. These models you practice and you get good marks. Here first year chapters, you concentrate on that weightage chapters, and here let us discuss next here coming class here second year topics. Wish you good luck, all the best. Thank you.